Everybody is a leader. No matter what role one has, we are encouraged to lead with excellence, confidence, and humility. For me, being empowered means being trusted, and this is what drives me in all my interactions with my colleagues. Accenture's most important assets are its people, so investing in their well-being is crucial for our business. In the past 10 years, I've had many roles, but I've stuck to one domain, and that is railways. Mobility as such raises more than interesting questions for the future. Integration and orchestration of different ways of transportation in a huge metropolitan area, for example, is one of them. Railway will play a very important role in this ecosystem. Dedication is the key for me and for the more than 150 colleagues working in this domain. We are fortunate to have great clients who are real market leaders and disruptors of the domain. And only by evolving day by day in a truly client-centric manner will we succeed. So it's trust, confidence, and dedication, the secret recipe that we use each day to build something for tomorrow.
So hello everybody and welcome back to our second keynote at the Romanian Testing Conference in 2020. Today I'd like to introduce you to another Shiro who really knows that you need a lot of heroes and Shiros to create an impact. Tanja is not only a professor at 2 universities, but she's also a member and founder of many international testing projects. Her goal is to make software testing more sexy. So Tanja, please tell us about that.
Thank you, Vera, for the introduction. So indeed, my keynote is going to be about how to make software testing more sexy. I want to start a little bit with about myself and indicate how I got here. So I did my studies in Utrecht. In my master thesis, I finished that in 1995. Then I did my PhD in Utrecht, finishing in 1999. And then in 2000, I went to Bolivia to supervise some master students. And then after that, I went to Spain, where I started as an assistant professor at the Technical University in Valencia in 2004. And I became an associate professor at the UPV in Valencia 2009. And finally, in 2016, I became a full professor at the Open University in the Netherlands. So my thesis work my PhD work was about formal methods. So I had some ingredients what I should work. And it was, on the one hand, a theorem prover for proving theorems about higher order logic. That was called whole for higher order logic. I had a specification language, which was called Unity, that we could use to specify the workings of distributed algorithms. And I had an embedding of this specification language in this higher order logic theorem prover. And I had a bunch of distributed algorithms to prove. So in the end, what I did during the 4 years of thesis was building a stratified approach for verifying families of these distributed algorithms. So this was very formal work on proving the correctness of algorithms. And to give you a small hint of how that was, here you see on the slides a specification of a distributed algorithm in this specification language that is called Unity. And you see on the other hand a property. And the idea is to show that this specification actually satisfies this property. And the show means that you should verify this correct by decomposing the property into true, basically. 1 is equal to 1 to show that indeed this specification satisfies this property. So after doing my PhD on these formal methods, I moved to Spain in 2001, and there I started working at a technological institute for information technology in Valencia, and my mission there was help companies to become or stay competitive, software companies basically. So, well, there I was with all this knowledge I had on formal verification and correctness of distributed algorithms. So I went to visit these companies to see how could I help them make their software better. And I found there lots of small and medium-sized enterprises that in the time that I went there were a lot of these companies that made ERPs, so enterprise resource planning software. And what I found there was companies that actually created monsters of software throughout years of development on this software, trying to get all the requirements that they got from different clients in. And then they would present such a software monster to me. And actually, I would ask, so where are the requirements? Well, there were no clear requirements. And okay, so how do you test it? There was no testing. So I was like, okay, so what am I going to do here? Because I've got all this formal methods knowledge on how to prove correctness of algorithms, but I need specifications to do that. So this is actually when 20 years ago, my journey started in software testing. And what I tried to do at that job was help the companies to improve their software quality by using software testing. And at the same time, I started doing research on software testing. And I actually, in that time, I set up my first project on evolutionary testing, which was funded by the European Commission in the Framework 6 program. So it's a long time ago. Then I found out that in this journey that I started, going to companies, doing the research, trying to explain to people what testing was, I actually found out that testing is not sexy. People do not find testing sexy, and they actually do not really like talking about it as much as I do. And so when I was preparing for this talk, I tried to figure out, so why is that? What is the problem? What do we need to do to fix that? And actually, I think that testing is not sexy, and we are in a vicious circle about that. Because it is not sexy, we have a lot of consequences that it finally makes it not sexy. So first of all, since testing is not sexy and people do not really want to listen about it, it's very difficult to explain to people why it is important. It's difficult to keep their attention while you're explaining what it is and teaching about it. And people are bored because, well, it's not sexy. So if people do not pay attention to what you're telling them and they do not get the message and don't understand what it is, so then they cannot really understand and tell other people why they should do it. And hence, they don't do it. Because testing costs time, effort, and money. And if you don't really see why it's important to do it, well, then you don't do it. And if nobody does it, at companies principally, then we have all these students and other people saying, I don't really want to learn about this because nobody does it anyway, so why should I learn it? And well, then we are back to where we were, because if we have a topic that nobody really wants to learn about, then it's actually not really sexy. So we are in this vicious circle that we need to get out of. And in order to find out how to get out, maybe we should go back a little bit and see, why is this? Why is it? Why get people bored when we talk about testing? And why is it not common practice at universities and companies? So I'm going to look a little bit into the different parts of people involved in software testing. So on the one hand, we've got the academics, we've got the companies, and we have the students. So let's look at all of them briefly, starting with the academics. So in 1969, there was this saying by Edgar Dijkstra. Well, Edgar Dijkstra is a Dutch computer science pioneer who's very famous and who did a lot of important work in the computer science community. And he wrote this, this paper in which he said that program testing can be used to show the presence of bugs, but never to show their absence. And then he continued that therefore program correctness should be proved on the account of the program text. So this phrase became famous. Everybody that I know that wants to advocate their formal methods, including me when I was doing my PhD thesis, use this phrase to show you should not use testing because it's not enough. You should do formal methods. And so people thought that testing was no good and correctness was needed through the use of formal methods to show that your software was working. Yeah, and people using this phrase all the time, it's got something, more value to it, that testing is something bad. And as a result, there's very little amount of research on testing at university. It's starting to get better, but it's far less than, for example, the research on formal methods. And as a result of that, there is not enough testing in the computer science curricula at universities. There's far more emphasis on these formal methods to prove correctness. So that, on the one hand, is what happens at the universities. So on the other hand, we have the companies. So for companies, testing is expensive. And there is a problem that you have to do something that is expensive, and you have to make cost and put effort into it and plan it, but you don't really directly see visible and tangible results because you don't create something, you test something. So for companies, there's a problem of finding what is the return of investment that I get from doing all this extra testing and making all these extra costs. So companies struggle with that, and as a consequence, they most of the time test too late or inadequate. And they really start worrying about testing and the quality of applications when it's too late. And then you get things like you see here on these slides. You get problems with lawsuits because there was software failure. You get loss of money. Even we have loss of life or damage to the environment. Software failures can have lots of impacts, and then it costs a lot of money, and even worse than money. So that's when companies, if this happens to them, start thinking about the software quality. And then we have the students. The students, we did not educate them enough to do testing. Yeah, we just let them hand in exercises without testing, and they can pass the exercise. We also let them hand in exercises with bad testing, and if it works more or less, we let them pass. And so they're not used to do testing because we as teachers do not really always ask this from them. And then the other problem is that the software projects that our students are involved in are very small projects. And they implement their software, they hand it in, and that's it for them. So they do not actually feel the pain of what it means to hand in a piece of software that is of not good quality, that has not been tested well. And if you have to take this piece of software and continue developing on it. Yeah, so adding more requirements to it or changing some requirements and then making sure that everything that was there still works well. Students do not do these things. They don't know how horrible it can be if you have a piece of badly tested software. So, and finally, back to the students, they don't know why they have to learn it because they have seen what happens in companies, and in companies they don't use this. So they say, I don't know why I need to do all these things because the companies don't use it, and we were back at where we were. This is the problem we know. So this is a problem, but still software testing and software quality is very important. And here's, for example, a slide with some data from the Software Fail Watch, which is an initiative from RTC2020. And there the Software Fail Watch, what they do, they watch stories. They collect all kinds of news stories, and they collect them based on software failures and the amount of money and failure that has done. And they actually found that there's 3.7 billion people affected by software failures. And there's more than $1.7 trillion involved in all these failures, in the costs and repairing them. So there is a real problem, and there is real evidence that testing your software is very important, but still we cannot get this across to people. And then there's more problems. There's problems about people fighting with each other on terminology. For example, in 2007, there were ISO work groups that started working on international testing standards. And from the period of 2013 to 2016, they published 4 parts of this standard, the 29119 ISO International Software Testing Standards. There was lots of critique. People were really angry about that specific standard. And there were things like, it's a confused mess. Yeah, we should sign a petition to stop this ISO standard, and people indicating that this is precisely the way to not standardize testing. And what people would argue is that these standard initiatives, although important, what they try to do is make testing an overstructured process that would put a lot of bureaucratic documentation and paperwork on top of testing. And that this was dangerous for testing because testing is a craftsmanship. You have to be creative to make sure that you do testing well. But if you are like restricted by filling all these papers and doing all this bureaucratic stuff, then you cannot concentrate on the creative part. So these are basically things between schools on software testing that fight about what testing is and how you should best do it. So there's, for example, the analytics school, and there's the context-driven school. So the analytics school is where it's basically proponents in academia. And what they say is that testing should be based on specifications. If you do not have specifications and you do not have clear requirements, you cannot test. Yeah, and you need to do model-based testing. You have to base your testing on formally mathematically grounded models. And that is opposed to the context-driven school, who say you have to adapt to the circumstances. Yeah, you have to do exploratory testing. You have to explore and learn what the software is about to make sure that you can find these errors. And they say testing is not formal. And so these schools do never agree with each other. So, for example, I was in a discussion with both schools on the word formal. So the word formal in an academic setting, where you look at the people from the analytics school who do formal methods, for these people, the word formal immediately brings. A couple of days ago, while preparing this talk, I went into Google and I put definition of software testing. And on this slide here, you see the first 3 hits that I found. So let's look at what these 3 first hits in Google say about what is the definition of software testing. So the first one here says, software testing is a method to check whether the software matches expected requirements and to ensure that software is defect-free. Well, this is obviously already a wrong definition, because although maybe Dijkstra saying made people at academia think that formal methods were needed instead of testing, he was right by saying that you can only use testing to show the presence of bugs, but never their absence. So it is impossible to do testing and afterwards say this software is defect-free. So the first definition that I got as a hit on Google is already plainly wrong. But it goes on. It involves execution of software and system components using manual or automated tools to evaluate one or more properties of interest. So it's a method to check and to evaluate, and, well, defect-free, which is plainly wrong. Then we go to the second definition on our Google hit, and it says software testing is a process. So it goes from method to process. And obviously, we can discuss forever what the difference is between a method and a process, but we're not going to do that. It's a process to evaluate the functionality of software application with the intent to find whether the developed software met the specified requirements or not, and to identify the defects to ensure that the project is defect-free. Again, the second definition goes on the defect-free part. You cannot show that your software is defect-free with software testing. And there's another problem with this definition. It says that software testing is there to evaluate functionality. But software testing is much more than that. You can use it to test functionality, performance, usability, accessibility, installability, all kinds of characteristics of software. So not only functionality. So the second definition is also actually wrong. The third definition comes from the Wikipedia. And we can already see that this definition is quite more modest. And it says, software testing is an investigation conducted to provide stakeholders with information about the quality of the software under test. Well, we cannot say a lot about that, because it's a very short definition, and at least it does not contain anything that is incorrect. But what strikes us is that we have 3 definitions that we find on Google in the first search, 2 of them are incorrect, and 3 of them say it's a method, it's a process, it's an investigation. So there is problems also about what is software testing and how do we define it and how can we make everybody see that it's the same thing. So the way to break this circle, this vicious circle we're in with respect to software testing, what we need to do is change this in education. Yeah, and we've already seen the keynote this morning with Kari Kakkonen, who already wants to start teaching the kids how to do software testing. Well, that's precisely the way that we have to start. Although what I'm going to propose here, what we do is basically at the university level. And well, this is very basic, no? We educate students that become the software engineers and testers of the future. So they go to the companies and universities after, and that's where they should start breaking this vicious circle. So what we do in the courses that we give at the university, we start with an alternative definition of testing. Now, testing is not a process or a method or an experiment or an investigation. Testing is a search. It's a search for an unknown quantity of an unknown type of failures in software applications by means of selecting and executing a limited amount of test cases from an infinite amount of possibilities. So this definition is far more interesting because it's a search. And what are we searching? And it immediately gives the students an exciting point of view and to ask and learn more. So they ask us, what are failures? And why is the quantity actually unknown? And why can we only test a limited amount of test cases? And why are there infinite possibilities? And if they ask these questions, they already touch upon very important characteristics of what software testing is. And the fact that you cannot show that your software is defect-free when you're tested. You just have to make sure that you select the best test cases and do the best job you can to make sure that you have tested well. So the students want to know, so how do I search? And when do I know that I've searched enough to very other important questions in software testing? And then we teach them that it's difficult, this search, but we can manage if we do it both exploratory and model-based. We educate our students that both schools are right, because actually they are. For an effective search for failures in software, first, we need to explore. We need information. We need information about the products, its usage, the users, the requirements, the purpose, the risks, etc. And how do we get this information when we are confronted with the system under test? Well, we explore. We get this information by reading, questioning, studying, observing, inferring. We do everything we can and use our common sense and our creativity to get the information we need to know the testing problem we have at hand. And then what we do, we use this information to make a model. And we make this model, we pick some coverage criteria to cover the model, and we make our test cases. And this way, our testing is both exploratory and model-based. So these models are needed to put the structure on our testing, and the exploratory skills are needed to make good models. Models that actually are ensure us that we do good testing. And it's very interesting to actually see that the analytical and the context schools fight. But basically the analytic school people already do exploration, because if they don't explore, they cannot really make a model. And on the other hand, the exploratory testing people already use models, because maybe they don't use the really formal academic ones, but they do use models, because models come in many different ways. So for example, here we see 2 models on this slide. These are very simplified models of, on the one hand, the universe, and on the one hand, the world, the globe. They're very, very, very simplified. There's lots of details missing here, but still they're very useful to actually learn some things about these 2 concepts, about the world and when it's day and night on different parts of the globe, etc. So models are simplifications of reality, and they come in many different levels of details, abstraction, and formality. And that is what we learn our students, that there is lots of models that you can use for testing, and we actually start with the easy ones. So the course we've developed, and you see this here, is a course where we have concentrated on test case design and show our students that this is exploratory and model-based. And so we give them tasks to practice their creativity and their common sense to find the information they need to make good models. And we give them the techniques to write the models. So the models we see in our course are equivalence classes, boundaries, decision tables. Yeah, for us, although these are very broad interpretations of models, we directly want to show our students that these are the things that we use to structure our test cases. And if we start thinking about equivalence classes as models, you easily see that I structure the information I got while exploring about my system under test, and I'm structuring this in classes such that I can select test cases. And then we go from decision tables to classification trees, all the way to the formal IOCO testing theory using label transition systems. We show them that too. So we have done 1 year now running this course, and well, obviously there's always different opinions about that, but we see that most of the students are very excited about this topic. Obviously, there are some exceptions still saying to us, oh, but companies don't use this, and why are the specifications so fake? So we still have some work to do to let people know what testing is about, but we get so many positive comments about this course that we just continue doing this and showing students that testing is actually both exploratory as model-based. So I'm concluding my talk with this and putting up this slide. Is anybody still here?